Hello, this research is about experimental investigation of the skeletal adaptations of deep sea sponges by Maria Jose Valbuena Mendoza, and it was carried out under Mauricio Porfiri and Nico Ulbricht in the Department of Tandon, specifically in the Dynamical Systems Laboratory.
A glass sponge seems like a fictional concept, but it does exist. Eupolectella aspergillum, also referred to as Venus flower basket, can be found in the deep sea where the water currents are extremely slow, making the living conditions extremely harsh. Our interest in this sponge directly relates to its skeletal structure. The lattice and the helix each play a distinct role in reducing the drag coefficient and increasing the flow residence time. The low drag coefficient allows them to navigate the water column with minimal energy expenditure, protect their delicate skeletal structure, and remain well adapted to their unique ecological niche. The high residence time means that the water remains inside of the sponge longer. In the deep sea, nutrients are scarce, but when the water circulates for longer, it increases the chances of successful nutrition and also sexual reproduction. In this project, we developed an experimental test bead to look into the hydrodynamic performance of different skeletal adaptations of deep sea sponges. The first part of the experiment is based on previous computational analysis done in one of the top 10 world's fastest computers. By physically replicating the experiment, we can confirm the previous results. A water tunnel and particle image velochimetry are used to reconstruct the velocity and pressure fields of the three different models. It works by introducing small reflecting particles into the water and shooting a laser to create then a camera captures hundreds of images, and through software, we are able to recreate the vector and pressure fields. This way, we can physically check the previous computational experiments and our experimental setup. Then, we can proceed to explore what happens when sponges form bouquets. Does the drag coefficient and residence time are altered? Is this part of their evolution process? These are topics that will be explored in our future research. But why do we care? A low drag coefficient is one of the most important features any transportation system needs to have, as it optimizes its energy usage. Therefore, it can be implemented in submarines and other naval systems. Residence time can potentially be used to increase water displacement and therefore increasing efficiency. Our research will be targeted towards naval applications, but further applications can be explored.